So let's start. So hello everyone, my name is Sergey Simonenko, I'm CTO of Bohemia Automation, and today we will talk about digital frontier, about security technologies in industrial IoT. Bohemia Automation, we have own automation platform, and it's used in high heavy industry, in high energy sectors. We have enterprise customers around the world, and I can share some details how to make everything secure, not like from technical side, because this presentation is actually for everyone, but we'll definitely talk something, get some topics from technical side, and let my colleagues present maybe themselves. Maxim, can you start? Maxim, hello.
Can you please start?
Yes, you need to present yourself, actually. Okay, let me present Maxim. He is actually our Chief Communication Officer, but actually today I will be communicating the whole time. And let me present Alexander. Alexander, do you want to present yourself?
Hello, my name is Alexander Chernych. I'm a professional investment advocate and lawyer with 20 years experience, and I want to be a part of this project also as a part of Cyber Scottish Week, and we are presenting few Ukrainian projects, very great and very smart project in energy, IT, and legal system. So we are all in attention. Sergey, listen to us about your program, about your product, and what you can give for British market, for Scottish market, and for international development of an energy and IT sector.
Okay, thank you, Alexander. And I want to warn everyone once more that this call is being recorded. This event, not a call. It's been recorded even twice from my laptop and from my computer. So let's start. The first slide, a little bit about history. Actually, how have been started industrial IoT. We can actually split in 4 epochs. The first one was in 70s. Actually, in 1968, the first PLC appeared. It was made by Richard Morley from Modicon, and from General Motors, and it was called Modicon 84, and it was the first PLC on the market. Actually, it was the first idea to use some computer to make to do some industrial work. The second actually epoch was in approximately 90s, when people started switching to personal computers. Actually started using Windows, especially Windows NT, Windows NT embedded, and the good example was TwinCat, developed by Popup Automation. This is company who used it was the first company who used, probably the first one, who used general purpose personal computer for industrial applications and made it real time. And as a final, actually, we can end this epoch with release of OPC UA. This is still a popular standard of data exchange used in industrial automation, and a lot of industrial applications, sometimes even in field bus, and it still works still pretty popular. The third phase actually was in in year 2000 it started, and it maybe even continuous, it still continues when everything started moving to cloud. So actually, everything probably started with MQTT. MQTT popularized clouds in industrial. Actually, some people think that MQTT is just for built initially for home automation. No, it's actually was built for industrial automation. It was actually a British engineer, Andy Stanford Clark from IBM. In 1999, he developed this protocol to control oil pipelines somewhere in the United States, but it was just regular SCADA protocol, and the only difference, it was truly like not decentralized, but truly scalable, yeah, scalable between different nodes, different plans. Actually, we know lots of lots of negative sides of MQTT. For example, you can't see who actually put data into a topic, but never mind. It has become popular in at the end of year 2000s because Andy used it to put some data into Twitter and social networks from his home automation, self-built whole automation system, and the protocol has become very popular, and big cloud players, it was start of cloud age, and they started to provide MQTT as embedded. For example, Amazon IoT, they have just regular Mosquito in the core, and they provide you it as a service. But actually, it was quickly found that clouds are insecure. You can't put, for mission critical production, you can't put everything in the cloud. Of course, you can put some statistical data, you can put some interfaces, not mission critical ones. You can put even some data exchange points, but you need to make sure they are securely encrypted, because we can't trust clouds. We can't trust cloud because they are working just regular people who can be blackmailed, who can be bribed, and so on. So everything is moving back to edge computing, but with first it's moving back with cloud technologies. So actually, what did we have in 90s? We call it clusters, but now we call it edge cloud, and there are a lot of tricks from real clouds coming to edge. For example, Popup model, it has become like a standard in any industrial clustering for now, and actually you can enterprise still uses some is using some cloud parts, for example, to store some data for statistical analysis, for big data, for so on. Good example of this can be Siemens Industrial Edge Platform, actually released by Siemens about 3 years ago. So it's actually a cloud, but you control everything. Backup automation, actually, I'm big fan of this company. They are moving to BSD. I consider is a very good step of edge computing integration to move to open source. And to use BSD instead of Windows. And of course, our company, we are also releasing EVA ICS, which is focused on actually edge computing and make local clouds, local clusters, and control everything you have. So let's go next. Actually, Maxim, if you have some additional information, or if you guys who are listening to us have some questions, you can write them to chat, because actually usually we have questions time at the end, but I can answer some directly when speaking. So this is a page about local security. Let's talk a little bit about local security and why it's important. Actually, lots of even industrial IoT platforms, I'm not even mentioning like home IoT platforms, they miss good access control lists. For example, if you have Amazon and you use like PubSub, you put payloads with PubSub and you use some request to obtain data back, there is nearly impossible to construct good access control lists, especially if you have some bulk uploads and you upload the data from from dozen sensors in bulk. It's impossible to restrict access for a particular user to particular payload fields. And the next is actually like all modern platforms, they need to give good event accounting. It's very important. It's actually already had been realized in Windows domains. If you even managed Windows domain, you always you know that there is always a single event log for all computers, for all actions made by users, made by critical software, and everything is written in audit trail, and you can see anything from a single machine. And lots of platforms actually miss this feature. You can't have everything aggregated. The next is actually, it's very important to have, it's obvious, but nowadays some people just ignore it. It's obvious that you, if you see on this schema, you need to have field bus network fully isolated. It was obvious 20 years ago, but for now, we need to repeat it once again. Never put like, if you have critical like productional equipment, never put it in, not to the internet, but not to public networks. You always have a safe field bus network, which is isolated absolutely from everything, including from SCADA network, including from, of course, from public network. And this network usually have no encryption. Why? Because encryption is just overhead, and here actually encryption problems, for example, certificate expiration or something, can lead to production accidents. For example, you can't be happy when a machine is stopped because a certificate has been expired. So let's keep field bus like it was always. Like from start of PLC age, field bus network it was physically isolated because it used protocols which were unable to be routed directly to general purpose networks, for example, Modbus and DNP3 and so on. And so even if we use MQTT, even if we use Modbus TCP, even if we use we are using some protocol which can be routed to TCP API networks, we need to make field bus network isolated. That's obvious. The next level is actually about on the scheme is platform like semi-trusted network inside the company. Why is semi-trusted and why is partially encrypted? Because inside the company, you can imagine, for example, it's single operation center where, for example, about 10 operators, and they know each other. They have physical security. They have this network physically protected from outside. So you don't need to make everything encrypted. You don't need to have additional overhead. If you physically control like all switches, all routers in local rack stand, so you don't need to encrypt this data. And the next level is, of course, like network, public network, also gateways for remote users, VPN entry points. We are going to talk about VPN today also a lot, and this can need to be fully and completely encrypted. Fortunately, we have TLS now everywhere, and TLS can be very simply implemented like both programmatically or using DevOps technologies. You can install a TLS terminator third party on any SCADA, on any automation platform. So everything is safe with Fieldbus. So let's go next. Actually, it's obvious to have minimalistic incoming communication. I'm talking to I'm explaining my students for 20 years that the best protected port is a closed port. So if a port is closed, it can't be physically attacked. So you can put the best firewall on it. You can put the best access control list. You can put the best authentication system, but better just to close it. Never do lots of incoming communication. Never open even SCADA ports to the internet. That's obvious, but need to be repeated nowadays because sometimes people share just incredible information. For example, they are putting security cameras images to clouds. It was impossible 10 years ago, but for now everything is going to clouds, and for mission critical system it just it should be restricted. Next, to use dedicated operating system distributions, and maybe to include here also to use passwordless kiosks. For example, our platform EVA ICS, we are using passwordless kiosk technology when operator he gets some computer he can't even he can't control, and he even doesn't know his login and password. So when an operator comes to his workplace, it's remotely logged in with one-time password with specific set of access control lists. And if this computer is compromised, is stolen, and something happened, the most important was a computer is installed somewhere in the field, for example, and accessed by technicians from time to time when they repair something in power boxes. So these computers absolutely don't have any passwords, and if a computer have no password, it's completely useless for physical attackers. And the next, actually, why do we recommend using dedicated workplaces, dedicated kiosks? Just ridiculous story about Google Chrome and actually Chromium engine from the year 2022, it started putting inactive tabs into sleep mode when there is a lot of JavaScript running in virtual machine. And the problem, like everyone has got now, web SCADA interfaces, and operators started complaining that we have session timeouts, our HMI interfaces are locked out or are freezed because of this Chromium engine feature. And when actually we asked our customers why actually, because this happens only for inactive tabs, they explained to us that an operator, when he's looking into SCADA machine and actually monitoring what's happening in production, sometimes he wants to read news, sometimes he wants to go on the Facebook, sometimes on other social networks using the same computer, and this is just ridiculous. One moment, actually. one moment, because people are complaining they can't write to chat. Here is actually everyone can send messages. Everyone can send messages, but
Just raise your hand and
can someone please send a message into our chat? So let me just viewers. Oh, that's strange. Because actually viewers should be allowed to put messages into chat. Okay, they have 10 viewers. Maybe we can make actually everyone contributors, but don't overuse this, please, because you will be removed from the call. So I'm making everyone contributors, and you can now ask any questions. And one moment. So everyone is a contributor, and you can ask any question in chat. And one moment, we still have 2 viewers. I can't make probably, I don't know, I can't make 2 people contributors. Okay, maybe they need to rejoin. Okay, one moment. Okay. Maybe they need to accept requests that they are contributors, because actually Google is not the best platform to present. I must admit. So let's continue. So it's really a problem that people are using like computers for everything. They use them bots for industrial automation interface, and they use the same computer for social networks. Of course, from the security side, it's just not ridiculous but dangerous, really. So we have a question: how do users log in? This password-led box, is there some mobile code? Let me explain. Each box, it has got some ID. So consider it's working like DHCP for IP, and it works the same for authentication and for SCADA. So there is special software, we call it like EVA panel. It's specially built WebKit web browser. And when it's opened, it can be automatically logged in with some one-time user, or remotely relogged in with some different user. So actually, when like plant administrator want to give operator some special access, is mostly used for technicians, actually, when they work in field and they need to open a power box, and there is a kiosk, and they need to access for some special specific part, get some specific access control list, and get even specific SCADA page. And so they just you can open for them this page, and actually this everything can be automated. For example, when something fails, Powerbox automatically opens this page, and when a technician arrives, this page is logged in. So we actually interact between like our special IPC network, between system programming part, and between JavaScript, and so everything plays together. And for operators and for technicians, everything is seamless. So you can do you can assign access control list, you can switch page of this kiosk, and operator workplaces the same like you do with IP address and DNS settings in the HTTP. So let's go next. So let's talk now about cloud security. So of course the best cloud nowadays is edge cloud. It's just it was obvious before, but now people are going back to edge, and because when you are on edge, you can control everything physically, and this is very important. You are sure like everything is running on your hardware, and there is no backdoors and hypervisors. There is no problems with technical stuff, because let's make a little bit spin-off here. Um, I have been working in security for. I'm not a security specialist, but I've been working in security a lot, and sometimes we have requests from big companies, from government organization to catch someone, and to catch an attacker who used 2 or 3 private VPNs to jump between hosts and to finally attack someone's server. So how do we use it? You can get private VPN, you can be security specialist, you can install a VPN, you can be good hacker, but in every data center there are people who are working there. So these people can unofficially or officially accept requests and just dump your virtual machine completely, even with your memory when you are logged in. So it was a very good technique to catch hackers, because hackers was working on this virtual machine. A hacker was working there, but we got a dump directly in live mode. And so never trust anything installed in data centers if you are both attacker or security specialist. That's advice. So the best cloud is actually the cloud you control completely. The next one is about PubSub. So all models here, especially in industrial IoT, they are using PubSub like a single exchange point. It's very useful because actually in large distributed network, they don't need to see each other. You don't need to have VPN between these nodes. You don't need to have ports open. You can install a single point of data exchange, call it PubSub. You can use MQTT, or you can use Apache Kafka. You can use some special protocol. For example, we have special in-house protocol called PSRT. Is also even IANA certified, and we use it to communicate with computers installed in in environments where the internet is pretty weak. So MQTT just dying there, but our protocol survives. So there are lots of PubSub protocol, but the idea, you can't trust PubSub absolutely, because PubSub is a single point of data exchange, and it can be a single point of attack. And if someone controls your PubSub, he controls completely the whole cluster, the whole your cloud. So he can, for example, change some sensor metrics, to provide fake telemetry. And the most dangerous, if your platform accepts actions, an attacker can generate actions directly on your PubSub server. That's the most dangerous part. And we actually have lots of production cases when people want to have secure infrastructure, but they want to use some cloud some cloud PubSub just to exchange data. For example, we have free owned plans with on power plants installed system. Everything is secured, but we want to use Amazon IoT to exchange data. That's ridiculous, because they anyone at Amazon, anyone at any company there are people working, and nowadays we actually we have wars in the internet. We have wars around the world. Thanks God, we have no like third world war physically yet, but in the internet, in IT, we have attackers from both sides, like continuously making attempts to attack critical infrastructure. And as I already mentioned, there are people in these big companies who provide cloud services. People, even if they respect laws, respect like company policies, they can be blackmailed. They can be pushed like personally. For example, what an network operator somewhere in big company could make if his kids were kidnapped. Of course, he will do everything what attackers demand. So we can't trust any third-party company, even with good reputation. It just unfortunately a reality. So we have another questions from Igor. Speaking of running your own cloud, do you have any observation of having your own infrastructure with relying on cloud providers? Actually, according to our platform, all communications between PubSub are secured, and all communications between nodes are additionally encrypted, especially for actions. That actually makes EVA ICS platform unique, that we never trust PubSub, and even if you have PubSub attacked, or you have like cloud PubSub you can't completely trust, so everything is additionally encrypted, and you can be safe that it's the same like when you are sending data via the internet, but protected with TLS or like symmetrical encryption. What about costs? Igor is asking. If you mean about like software costs, it costs almost nothing. Like we have no overhead on CPUs or on memory with this. Like we have customers who exchange really a lot, like dozens of thousands metrics a second, but there is no overhead on because actually PubSub it doesn't do any encryption. It just routes data or is encrypted packet. Like a little complication, like cost, a little overhead is like people like DevOps. Development operations integrators are used to make small applications which are communicating directly with PubSub, with MQTT, and for example collect some data directly. When everything is encrypted, it's just impossible. Yeah. I have a note from Michael. Example of bribing, blackmailing, and employing could be also if you have Edge Cloud too. It just a difference that one of your employers was blackmailed and he has some problems, but let me explain about this. When you see something suspicious about your own employer, you see him probably like day by day, and security specialists, when you see something suspicious, they can just block all access. They can just block access even to workplace, like temporary, just and. If a local employer was blackmailed, he can probably have some trusted relationship with colleagues, and he can discuss. He can start discussing what to do. But if you have an employer who works somewhere in big enterprise company who provides cloud technologies for you, you have no direct communications. You are not even sure that this employer is in like. Speaking nowadays words, sitting in a friendly country. It can be an employer from unfriendly country, like working remotely on this corporation. because actually any corporations, they care more about profit, not about security. Security and reputation is always the sort, or even on the fourth place. So let's go probably. So about untrusted telemetry, actually, I already told you about it, and about cloud-wide even told it. I can just give you one quick example here. Go to have example of our HMI application running. Is what's dedicated HMI application made for wind turbines. It looks like this, but we go to operation center. It's our standard application, and we can go, actually we need system dashboard. We go to system dashboard, and on system dashboard we have events from the all nodes in this cluster. Actually there is a single node, but we can have anything all login attempts, all user actions, and everything of this. So let's go back to presentation. So it's very important to have cloud-wide event audit and to see all events. And let's go next. So let's talk a bit about Rust benefits. Why do we started using Rust for making industrial applications? Actually, when we switched from when we found this this sector is profitable, we switched from general purpose languages like JavaScript and Python to system languages and Rust already had got the best ecosystem on the market, but after we found much more benefits. So the first one is memory safety. You don't need to care anymore about classical exploits when some data packet can execute some code remotely in your application because some buffer was overflown. So if you are using Rust in safe mode, it's just impossible. Trade safety is just a benefit to have no data races. It's also sometimes important, but not for security. And of course, Rust gives you all C and C++ benefits, including bare metal and real-time application. Actually, this year we are going to release on PLC running in Rust, and there are lots of real-time operating system, especially for sectors not really standardized, but by government guys, drones and some automotive parts, not for for cars of course, but for small transport it can be easier to use, and for automation in various sectors to have special permission. And Rust is being certified. For example, we have BICOS, which already certified Rust for real-time application, even in mission critical, including automotive, including high energy, and so on. Of course, in countries which demand the certification. And so sometimes, to be honest, actually, sometimes Rust is faster than C. Because in C you are you're relying on pretty ancient ecosystem which just works. For example, on Linux you you are using usually GNU libraries, and they are not so heavily optimized like Rust applications, and because typical operations like string parsing, string formatting in Rust, they are made using macros. and in C and C++, they're usually made using like standard functions, like general purpose. Like Rust, for sometimes, is even better than C. Of course, you can make the same code in C, like a dedicated code, and it will be faster, or even it will have the same speed or be even faster than Rust. But for real world applications, when you can't optimize any like all functions inside, Rust is of course much better. Actually, the next benefits, Rust is immutable. Immutable by default. It means you just can't change data parts. It can be like a benefit from a programmer, but from practical side is a big benefit, for example, for data replication. Because if you know that data is replicated by Rust agents only, and these agents have no access to mutate some internal like this object has no neither internal nor external mutability, you can be sure the data cannot be changed during replication. So it can be also part of security. And safe abstractions, of course, you can use trace. You can replace like easily replace, like we use this in lots of projects. We are using replacing physical hardware with virtual and vice versa, and it works just perfectly. So let's go next. Let's talk a little bit about VPN aspects. We use the structure for about more than 10 years for both like personal network and for one moment. I have a question about PLC from Igor. Speaking of programming PLC in Rust, well, any difficulties fitting compiled code from microcontrollers? Actually, you know, like nowadays, PLC is not a microcontroller anymore. Like PLC is a program which is being executed on a general purpose operating system, and there is no like, yeah, no, not Linux. Actually, Linux, just companies just starting to have like to resourcing real-time capabilities of Linux. Actually, FreeBSD like core is much better for real-time applications, and historically, Windows was and still stays a good example of real-time applications, because a lot of enterprise, they make PLCs for Windows. For Linux, like we are focused on Linux, but there are lots of some technical problems. Linux core is not optimized to be real-time, but of course it always differs what do you call real time, because you know in energy completely like real time is about dozens of milliseconds, because like if you have like one moment. Like RCD, I forgot this word in English. RCD. Yeah, if you have RCD, because I'm not an electrical guy. If you have an RCD, so standard response time of typical RCD is 25 milliseconds, not even microseconds, but milliseconds. So if you have physically RCD, like let me explain for guys who are not electricians as well. Like you have this automatic switch in power box, which switched out when there is like circuit. So actually circuit breaker, and it has 25 milliseconds to react. So consider if you make some if you make some PLC which act like RCD device, it has 25 milliseconds to react. It's just lots of time according to real-time specifics. So let's go to VPN. I hope Linux will have like brilliant future real-time applications, and but still like we still have no like good examples with it. Well, like with really real-time application, I mean with top real-time, which can provide like top companies like the same Backup Automation. They can provide cycles with jitter about less than 100 microseconds, so you can be sure like your program works and there is no interrupts, there are no like problems with system scheduler, there are no problems with core, and everything is running just smoothly. So let's go next about VPN. So we use this technology. Let's probably start from the end. We use this schema. We use this architecture for customers. We use this for ourselves for decades, and it works just perfectly. Like never make VPN just peer-to-peer. Like make, of course, make them peer-to-peer, but make sure each peer has got connections to maximum other peers as maximum as possible. Because if you have like VPN connection between two peers only, and something breaks out, like you have routing problems specifically to these peer networks, and you have your VPN connection, it just gets dropped. But if you have a chance to access this like plant 1 or plant 2, this is my cursor, let me just show, yeah, you have a mouse cursor, so you have plant 1 and plant 2, they are directly connected. But if this connection is dropped, for example, some network problems, some communication problems, you still can go to plant 2 via plant 3 or plant 4. So it's very easy to do. It's very easy to set up, and after you can use any automatic network routing protocol. For example, we prefer OSPF, and you can give it cost, and you can give it like network topology, and everything, almost everything is discovered automatically. And nowadays you have open source OSPF, lots of open source OSPF implementation, for example, Quagga. And you make just your VPN really reliable, and it's no longer overhead for your security. It's your friend even, because using VPN you can access hosts which are inaccessible directly. The next one, actually, of course, for VPN, actually, you can use anything. You can use IPsec, you can use OpenVPN, you can use WireGuard, any like modern protocol. Of course, don't use PPTP, don't use something obsolete, something insecure. And but any like modern protocol can give you all benefits. You can make like lots of peer-to-peer communications. You can put automatic routing protocols over it, and you have consider you have own internet inside the internet, and that's just brilliant. And we are using this for decades. So the next one is, let's talk about a little bit about crypto. So the best cryptography you can have in your platform is no cryptography up completely. Why? You need better to move everything to trusted libraries, because when you have in-house code which encrypts or decrypts anything, you can have lots of problems. The first one, of course, your code is not standardized. Like if you need FIPS 140 application, you have big problems with this. The next, your code just can have some mistakes, can have some bugs, and encryption can be much weaker than when you are using OpenSSL, when you are switching everything to third-party libraries. And the best cryptography is actually not to encrypt anything, but if you encrypt some communications, just avoid implementing TLS by yourself. That's because there are lots of TLS terminators on the market, and you can get any secure like verified by community, verified by big players solutions, and so just leave all cryptography to professionals. And we are not cryptography professionals, we are professionals in industrial automation, so all cryptography is outsourced. And actually, I forgot about VPN. If you have VPN, so think twice, do you need also TLS or VPN? It can be a big overhead when you have two hosts connected via VPN tunnel, and you are also using TLS over it. So you have double encryption, and if, for example, our platform encrypts data between PubSub and plans additionally, so you have triple encryption. So avoid using TLS when it's not a mandatory thing. Actually, TLS is for public networks and for networks you can't trust. Like for networks when for local networks, when there is lots of personnel which have access to it. So this probably was the last slide, and we can go to questions. So I have questions for Bogdan. If there are no VPN inside network, then someone can connect physically to cable. So it depends on security level. Yes, of course. Like physical security, we'll talk about physical security tomorrow. Physical security is still like the most important security part. Actually, if you have seen like movies from 90s, like from Tom Cruise movies, like from the first Mission Impossible, you remember how did they hack like some very protected computer, like some military computer installed in some military organization? I don't remember. Actually, they made everything physically, and nowadays it was like kind of science fiction in 90s, but nowadays it's a reality, because you have actually everyone has got a smartphone. It's a computer, and you can use this computer to hack anything. Actually, I have a laptop which is just a little bit bigger than my smartphone, and 20 years ago it was a special hardware used by government, like by rich government spy organizations, only by government agents. Nowadays any kid can have a mobile phone which is more powerful computer than a computer which landed Americans to the moon. So physical attacks now, and of course you can have flash drive, you can have like micro SD card, you can have lots of like data storage devices which are really tiny, and they can even be implanted in your skin. I don't know. So actually, physical security is very important. Yes, and we'll talk about this tomorrow. So if there are more questions, because I answered a lot during the presentation, let's give maybe 5 minutes to guys to write questions. Maybe one moment. I will see.
Guys, please feel free to raise your hand and ask a question, or just
Because we have problems with chat, so I made one more participant contributor, so you can write questions and you can actually talk. Probably, let's
just unmute your microphone.
Yes, anyone actually can talk, I guess. So let me have a break for a couple of minutes, and you can write or ask your questions by voice. And Maxim, can you help me with questions actually?
Yes. Sergey, it seems like we don't have any questions. You answer all the questions.
Yeah, good. Let me just
Plus,
show you some. Just
you
show
present.
you some interesting things actually about, because actually I tried to make this presentation not a product placement one. Yeah, it's called with EVA ICS, but people usually don't like product placement presentation. So let's talk about EVA ICS at the end. So this platform can be installed for free. We have like lots of home automation guys who are using it, and you can install it on any Linux. And we have lots of services. Like we have on microservice system is very similar to Kubernetes, but we don't use Kubernetes because actually it can be integrated with Kubernetes, but we have some special benefits made for an industrial company, customers, like they demand. So we have like own format of microservices, and we have lots out of the box. And you can have lots of authentication, you can lots of SCADA automation, and for database and for data replication. And the most important part is field bus. So it has got lots of protocols just out of the box. You install, you have everything for free. And as a system monitoring controller, it's a new one, so it can replace you even Zabbix. You can monitor physical computers with it, not only field bus. The only difference between like enterprise and free version, like in enterprise version, you have enterprise services enabled, like Active Directory, like the mentioned kiosk manager, and some others like zero failure replications. And of course you can start without. What about special? Actually, we have applications for Grafana. We have some applications like this looks like in Grafana with our dedicated application. And we have like standard interfaces like this. The mentioned operation center, so we have own like dashboard editor, similar to it's not similar to Grafana, but similar what, for example, backup automations they have got in their TwinCat. So you can put just any element on, like just one more gauge, and assign something and so on. And so actually, it's typical SCADA interface you can have. You can have some trends. Let me just show you. So let's go to more interesting parts. You can have this in any SCADA, except this is decentralized in EVA ICS, so everything works. But in EVA ICS, you have a Benjamin React, and the Benjamin React is just super powerful engine to make own web applications. So for example, this is an example of all components, and if we go back to this application. An application like this and can be built in one day, because like you have all standard components, you just put them in React applications with like React plus TypeScript, and you have like the core engine in web browser already connected to SCADA. So already have data, you have special React hooks, and you don't need, actually you need only to invent what to display. That's all. And everything is provided automatically, starting from low-level hooks, ending with UI components. Like, for example, for get you have a component, for char you have a component, and for everything, for button you have a component. You can make own component, or you can use like standard. And actually, we have also a machine learning kit, but it's out of these topics. But the most interesting for engineers is probably virtual field bus simulator. So that we can completely simulate now Modbus and TwinCat ADS. It's probably the best ADS simulator on the market. It can simulate real TwinCat. Of course, like if you are developing something, you don't need to simulate TwinCat itself, because Bechhouse they have policy. You need to just enter a code once a week and get your free trial for 1 more week once again. But if you are testing something, it is not useful, because you need to have deployment technologies. And the devices, you have lots of deployment technologies, starting from configuration and ending with virtual and real items. So that's just a comment. The dashboard looks nice. Nice, thank you. Actually, that yes, because this is like custom-made application, but you can make this if you have like template prepared with HTML, and you have like everything designed, so you can make this in one day. Just putting standard components. The demo only difference that actually I ask our guys to make the switch like dedicated, because like standard switch they look a little bit boring. And but if you are not good in programming, you can use visual editors and go with visual. It's like it's really optimized. It's not, it differs from Grafana because it's optimized for fixed layout, but it got own benefits. Like benefits of fixed layout is when you are making actually when you are making HMI interface for industrial applications, you not need it to be versatile, because usually you have like you have maybe 2, maybe 3 devices in your company when this interface will be used. Right. For example, you have standard kiosk bought from Advantech or some other company. You have standard operator points, and you have some standard microcomputers installed in power boxes, and you have probably can have a couple of mobile phones, and some operators may ask you to make them dashboards. And if you open some dashboard like made with Grafana or with Node-RED, and they just take a lot of space on your screen, as they are not optimized. And with like actually, it's not our idea, because lots of big players, they also use like static layout, and it's really useful for applications which work on specific screens. So let's end with the interface. It was just a funny part to show you, because actually I need to show something beautiful and Yes, to show something beautiful and nice, because people like interfaces. We have like this platform lots. It has got integrated with Node-RED, with MATLAB, with lots of Simulinks, with not lots of simulators, lots of field bus, and so on. But nobody was interested in it before we started making interfaces. When we started making interfaces, wow, we have it's just really nice, it's just really beautiful. You have a chart, this, or you can see this, it's moving, so it's already,
It's alive. Yeah.
yeah, so it's alive, yeah.
Typical.
It's alive,
Typical
and
app.
we are now seeing what we are going to install. So a question about if screen installed inside, if a screen is installed inside PowerBox, and data for share from central server or directly from PowerBox. It depends. It can work in both ways. Actually, you can put a tiny EVA ICS node inside a PowerBox and replicate some data directly into the PowerBox, and put this kiosk-like interface with SCADA and output like the local data only. Or you can communicate like with some central server. It's really flexible and it's up to you. It was a question from Baghdad. So that's all.
Seems like we run out of questions.
Yeah, that's good. That's
So,
good. That's
yeah,
good, actually. And that's all for today. And see you tomorrow. We'll talk about real cases of industrial infrastructure attacks. I will talk about some rumored cases, about some well-known cases, how are they made, and of course, we'll talk about today actually, it was lots of questions about it, actually technical stuff. The technical stuff is always a problem, because
weakest link.
attackers, yes, attackers, they usually work forcefully, they work with people, and only after they work with hardware, when there is impossible to work with people. Actually, if you know, the first well-known hacker, Kevin Mitnick, he was not a hacker but a social engineer. So we'll talk about this tomorrow, and
Okay.
thank you
Yeah.
for
Thank you,
today.
Sergey,
Thank you
for
for watching, for
insightful panel.
participating.
Yeah.
And
Thank you. Big thank you for our participation.
yes,
For the
yes.
involvement.
And
Yeah.
one more
So you mentioned we look forward for. Oh, we have one more question. No.
one more question. Yes.
No. It's a thank you. Okay, so guys, we'll look forward to seeing you tomorrow at 3:30 UK time on our second panel on
Actually, at the same time, because we have here people
same time. Yes.
from different time zones. So tomorrow the same time. Just
On
new link.
CyberScotland week. Yes.
Yeah,
Our
just
second
a
panel.
new link you have. So okay.
Thank you.
So I'm going to return to programming my old Panasonic notebooks. It's my new hobby. Yeah. I'm installing Linux and trying to make everything working. I need to make another presentation about it, but not at CyberScotland week. Okay, so
Okay.
see you tomorrow.
Thank you.
Goodbye.
Yeah.
Thank you.